In this video, we will discuss about torque acting on a dipole placed in a uniform magnetic field. We know that when a charge is placed in an electric field, it will experience a force, and that force is given by F is equal to QE. F vector is equal to QE vector, and the direction of the force is along the direction of electric field. Okay, so this is the force experienced by a positive charge placed in an electric field. But what will happen if you place a dipole in an electric field? Because we know that a dipole consists of a positive charge as well as negative charge of the same magnitude. So if you place a dipole like this point is positively charged and this point is negatively charged. So if you place this dipole in an electric field, uniform electric field, both the charges will be experiencing a force, both the point will be experiencing a force, and the direction of the force will be opposite because the charges are opposite. So the positive charge will experience a repulsive force and the negative charge will experience an attractive force. So if this is the direction of the electric field, then the direction of the force also will be along the direction of the electric field. And the direction of the force here, because it is negative charge, the direction of the force will be opposite to the direction of electric field. So what will happen if there are two equal forces acting in opposite direction? What will the result? The result will be they constitute a rotating force or a torque, and the torque will try to rotate this dipole. So this is a torque experienced by an electric dipole placed in a uniform electric field. Okay, if you have any doubts about the concept of torque, you can you can watch my video. I will give that link for that video in the description box. From that you will get an idea about the torque. Okay. Now, what is the force experienced by this positive charge? Suppose let us consider this is minus Q, this is minus Q, and this is plus Q. So this is the direction of the electric field. So this will be the direction of force Q E vector. Because of this positive charge, it is Q E vector. And here, since it is negatively charged, this will be minus Q E vector. So this is the direction of the two forces. Now the total force. What is the total force here? See, this is the uniform electric field. How to find whether it is uniform or non-uniform? The direction is same, the magnitude is same, and also they are in the equally spaced. So they are equally spaced. So this electric field is uniform. The charges are uniform. If charge and electric field both are equal, then the force also will be equal. So these two forces will be equal in magnitude and opposite in direction. So they will cancel each other. So the net force acting on this dipole placed in a uniform electric field is 0. Even though the force is 0, there will be a rotating force, that is a torque, that we are going to discuss here. So what is the expression for torque? Torque is given by torque is equal to, it is represented by tau vector, that is equal to the distance from the origin or distance from the center of the dipole to the charge and distance from the center of the dipole to this charge into the force. Actually, torque is given by the perpendicular distance from the axis of rotation. Here, this is the axis of rotation. So, perpendicular distance from the axis of rotation and the force. Cross product of the perpendicular distance and force is the expression for torque. So, here, this is the perpendicular distance. So, that is OA vector cross minus QE vector QE vector. This is one torque, and the another one is plus, what is this distance? OB vector cross plus QE vector. So this is the total torque acting on this dipole. Okay, now what will you get? The magnitude. Let us take the magnitude. So what is the magnitude? Magnitude of OA vector is equal to modulus of OA vector and modulus of minus QE vector sin theta. Why we are writing sin theta here? Because it is a cross product of two vector. A cross B is equal to modulus of A modulus of B sin theta. In the same way, OA vector means modulus of OA vector minus QE vector means modulus of QE vector sin theta plus OB, here also modulus of OB vector modulus of QE vector and sin theta. So what is modulus of OA? OA is the distance from the center of the dipole to this point, that is equal to A. So modulus of OA is equal to A. And what is modulus of QE? Modulus of minus QE means simply QE. So A into QE sin theta plus, here what is OB? OB is the distance from the center of the dipole to this point B, that is equal to A. So OB is equal to A and QE sin theta. So what will you get? If you add these two quantities, you will get 2QA sin theta. 2QA sin theta. And we know that what is 2QA E sin theta. 2QA E sin theta. What is 2QA? In the previous topic we have discussed that dipole moment P is equal to 2QA. So instead of this 2QA we can write P. So torque tau is equal to PE sin theta. PE sin theta, and in terms of vector or in vector notation we can write tau vector is equal to P vector cross E vector. Now what is the direction of the torque? We know that the distance, this is a vector quantity and the force is a vector quantity, and because of these two vectors the cross product of two vector is always a vector quantity. So torque also a vector quantity. Since it is a vector quantity, it should have a direction. So how to find the direction of the torque? That we can find using right hand thumb rule. See, for example, if we are taking the cross product of two vector R cross F, so tau vector is equal to R cross F. For example, what is R? R is the perpendicular distance. So this is the perpendicular distance and this is the force. So R cross F means I have to take my fingers along R and I have to curl that fingers in the direction of force. So this is the direction of force. This is the direction of R and this is the direction of force. So whenever I curl these fingers, the direction of my thumb gives the direction of the torque. So in this case, the torque is acting inward, or it is perpendicular to the plane of the board and it is acting inward. So it is represented by this symbol. This symbol means acting inward. Now what about this case? Here this is the direction of OA. This is the direction of OA, and what about the direction of the force? So QE is the direction of force. So I can take my hand like this. OA into QE. So I have to curl my fingers like this. Again, my thumb is pointing inward. So the direction of the torque is inward. So this is the method to find the direction of the torque in this case. Now, what are the special cases? See, instead of this alignment, if you place the dipole like this is plus Q, this is minus Q. So what is the angle between the dipole moment and electric field theta. Here we have given theta. Theta is equal to angle between dipole moment. This is the direction of dipole moment that we have discussed in the previous topic. Dipole moment is always acting from minus q to plus q. So this is the direction of dipole moment, and this is the direction of electric field. This is dipole moment P vector. This is electric field E vector, and theta is the angle between the two. If the dipole is perpendicular to the electric field, then what is the value of theta? Theta is equal to 90 degree. So case 1, when theta is equal to 90 degree, then what will become? Tau is equal to PE sin 90. Sin 90 is equal to 1. So tau equal to PE. So this is the maximum torque. So when the dipole is perpendicular to the electric field, then the torque is equal to maximum torque. The torque will be maximum. Next is case 2. So case 2, when the dipole is placed parallel to the electric field, like this. This is the direction of, this is minus q, this is plus q. So what is the direction of electric field? This direction. What is the direction of dipole moment? Same direction. So when these two are parallel, we can say that theta is equal to 0. Then what about tau? Tau is equal to PE into sin 0, 0. So tau is equal to 0. This is the case of minimum torque. So when the torque is maximum, when the dipole is perpendicular. When the torque is minimum, when the dipole is parallel to the electric field.